Hello.
Ma'am, am I audible?
Yes.
Okay. Thank you, ma'am, for your kind introduction. We will directly start with the session. So, participants, are you able to hear me? So, you can use your chat box. Yes. Okay. Thank you. Wait a minute. I'm presenting my screen. Yes, Rachna, ma'am. So, you have raised your hand. Any problem, Rachna, ma'am?
Sir, I can't hear you properly.
Okay. Maybe network issue from your side because I'm using the university network. Uh, Maybe there might be some issues from your side, probably. So, is everyone okay with my audio?
Yes, sir.
Yes.
Okay, okay, fine. Yeah, I'm presenting my screen.
Yes.
Thank you. Uh, yeah, thank you, sir. Yeah, yeah. Are you able to hear see my screen?
Yes.
Yes, sir.
Okay, okay, fine. So yeah, I'm going to present on topic statistical methods for data analysis in social sciences. So this is very broad area. Basically, we can't cover all the statistical techniques in the 3 hour session, but I will try to explore the techniques which are commonly used in the survey research kind of thing. Okay, so we will not talk about the statistical techniques which are commonly used by the statisticians, but these are the techniques which are commonly used by the social science people, okay, in their survey research. Okay. So I joined SP College in 2020, and I won't have much experience in teaching uh, as of now. So I have just spent 4 years in the teaching and 1 year in the Tata consultancy services. So that is what my experience in the professional life. Okay. So I have prepared a slide of only 19 slides. Okay. So out of which one is outline. So there are only 18 slides in my presentation. If you are concerned with the content. Okay. So this is the outline of my talk. So definition of statistics, collection of data, data cleaning and data reshaping, exploratory data analysis, and then data analysis techniques. So as you have seen in this outline, so I'm not considering all the techniques in the statistics, just focusing on the common techniques which are commonly used by the people from the social science background. Okay. See, the definition of statistics. So in the if you see this first one, it is something like data. Okay, we are having some data. I have some rows and some columns like age, gender, sex, current year, UG, PG, and faculty. Okay, so there is some data. Okay, so it is basically I have collected some data. So collection of data. Then second, I have represented that data by using some diagram. Okay, so I'm using some diagram to represent this data. And in this diagram, so this is basically representation of the data. Okay? Representation of the data. Next, again, after representing the data in some diagrams or some plots or some graphs, I'm using some summary statistics to analyze the data. Okay, so this is basically analysis of the data.
Data, collection of data, representation, and analysis.
Yeah, yeah. So this is the basically definition of statistics. So statistics deals with the collection, presentation, and analysis of the data And the last and most important step is, after analysis, we want to draw some conclusions out of that analysis. Okay. So the basically statistics is the branch of science that deals with the collection, presentation, analysis, and interpretation of the data. So that is what we are doing now. So this basic knowledge of statistics is required for each and everyone, irrespective of that so-called faculty barrier. Okay, so that our life will be more easier. Okay, so in terms of understanding some statistical techniques, we need to understand first population and sample. I hope you all are gone through the session, yesterday's session, that is methods of data collection. So I hope this is covered in the yesterday's session. Am I right?
Yes, sir.
Yeah. So what is meant by population? Can anyone just tell me what is meant by population and what is meant by sample?
Sir, population means the all the units of our research area, and sample means we are selecting some units from the universe.
Yeah, right, right. Very good, very good. So basically, population is not the census kind of thing. Okay. So population is the total number of objects under study. Okay. If we define, let's say I want to study the multidimensional poverty of the Pune city. Okay. I want to study that population. I want to study that multidimensional poverty in Pune city. So in that case, that the entire population, that census of the Pune city will be my population under study. Okay. So population is not same as census. So in statistics, the population, just 1 minute, that organizers are calling. Hello. Hello.
Hello, sir. Unable to listen. Your audio is muted.
Shantaram sir, please,
Yeah. Yeah. So am I audible now? Sorry.
you're audible, sir.
Yes, sir.
Now you're audible, sir.
Yeah. Thank you. Yeah. So the basically sample is a part of your population. So some objects will get selected into the sample from your population. That is your sample. So the sample is basically our data. Okay, this is our data which we are observing, and based on this data, we are applying some statistical techniques. We are trying to apply some statistical techniques, and after applying some statistical techniques, we are trying to talk about the population. So basically, the study of the population, entire population, is not possible due to some reasons. Okay, that reasons may be some economical reasons. Maybe that study of entire population is expensive in terms of money, expensive in terms of time, or even it might happen that that entire population is not known to us. Okay, we have only few observations with us, and that population is not known to us. In that case, we are just looking for the data, and based on data, we apply some statistical techniques, and we are trying to talk something about that entire population. Okay, so that is the main purpose of statistics. So in with the help of statistics, we are avoiding the study of that entire population. Instead of that, we are just focusing on some small sample, and we are trying to talk about that entire population. So basically, it is generalizing the results from some small amount of data to the entire population. Okay. Next, so there are nowadays we may get data from different sources. Okay, so there are some primary sources and secondary sources. Okay, primary sources of the data are nothing but the data collected by investigator itself. That is the very simple definition of primary data. So the primary data is the data collected by investigator or researcher itself. Okay, whereas secondary data is the data collected by some other agency, okay, or some other institute, or so you, if you are collecting the data or gathering the data from some journal, article, reports, in that case, that data which you are collecting from that journal, article, or reports, or books, or different online websites, that data will be secondary data for you. Okay, so the primary data and secondary data, these are the two sources of the data, out of which secondary data we can't control. Okay, we can't control this secondary data because it is the data collected by someone else. Okay, and we are just using this secondary data for our purpose. So we really can't set our objectives before observing the data. Whereas in case of primary data, we need to set up objectives before collecting the data. Okay, so in case of primary data, we are first setting up the objectives or aims of the study, and then we are trying to collect the data based on our objectives. Okay, so this is the more focused one, but it is not always possible to collect the primary data. So in that case, we go for the secondary data as well. Okay? So in most of the cases in your research topics, your data is primary data, that is the data collected by the investigator himself. Okay, and if you are collecting the data, you need to set up the objectives first. Okay, so defining the objectives at the beginning is very important if you are collecting the primary data. Okay? So that accordingly you can collect your data. Okay, so there are different statistical methods basically used to collect the data. So have you gone through these statistical methods in the yesterday's session?
No, sir.
Okay, so we will quickly go through all the statistical methods which are very important to understand. Okay, so basically, if we have a population, out of that population, we want a sample. Okay, so let's say this is my population, and we want some sample out of it. Okay, sample, few observations out of it. So some method needs to be applied. So that sampling method coming to picture. Okay, if you are simply gathering the data by just circulating Google form to your friends, so it will be a biased sample. Okay, so as I have already given and give you an example of multidimensional poverty data. If you are collecting or if you are studying that multidimensional poverty for Pune city, and you are simply collecting the data, let's say from that very rich area in the Pune, that is, let's say Koregaon Park, or that Hinjawadi IT Park, or let's say you are collecting the data from let's say SB Road. Okay, then that sample will be biased. Okay, because in your sample only rich people are coming. Okay, whereas no people from that below poverty line or middle class group will come into that sample. Okay, and you will end up with some wrong conclusions based on that data set. So preparing a Google form and sharing it with your friends is very risky. Okay, in terms of your conclusion. Okay, your conclusions will not be appropriate if you are simply sharing a Google form for a small group of people. Okay, so we need to diversify the responses. Okay, basically we want responses from different groups. Okay, so sometimes when the population is homogeneous in the sense that that uh, that individuals are not much different. Okay, individuals are not much difference, not of much different. In that case, it is okay. But if there are some groups in the population under study, in that case, we need to take care of sampling scheme which we are applying. Okay? So in this case, let us talk about that simple random sampling with replacement first. Okay. So yeah, just wait a minute. Yeah, okay. So if this is my population, so object 1, object 2, object 3, object 4, object 5, so and so many, okay, and so many. If this is my population under study, in case of simple random sampling, SRS WR, simple random sampling with replacement, we select some objects from the population, okay, in the sample, and let's say object 5 gets selected into the sample, and again we note down the characteristic under study. Okay, so if in case of multidimensional poverty, in that case we will check basic resources, their house roofing, house walls, house flooring, okay, then sanitation, then drinking water facility, all that variables which we are going to study, not just only income. So we will study this characteristics under study, and again we will replace that unit or object 5 in the population. That is simple random sampling with replacement. Okay, we are replacing that unit in the population again, so that that unit will be available for the next draw as well. Okay, so again we will select that second another unit in the population, which is in the population in the sample. Okay, again we note down the characteristics, okay, and again we are going to replace this unit in the population. Okay, so at each draw the population size is constant. Let's say at the beginning there are n observation in the population, so n observations in the population, then at each draw there will be n objects or n observations in the population which will be available for the sampling. Okay, and we want to select these observations randomly, not purposefully. Okay, so that is the simple random sampling. Okay, that is what randomness is coming into picture. We want to select this random observations randomly. Okay, whereas in case of second method, simple random sampling without replacement, so once that unit is get selected into the sample, that unit is not replaced back into the population. Okay, so if some objects, let's say some objects O1, O2, O3, O4 and O5, and there are so many. Okay, so and we are selecting a sample, and if let's say this object O4 is get selected into the sample, okay, object O4 will get selected into the sample, at the next draw we will delete that observation from the population. Okay, so this is the simple random sampling, without replacement. Okay, simple random sampling without replacement. So at each draw the number of observations in the population will reduces. Okay, at the first draw there will be n objects available for the sampling. At the second draw, one object will be removed from the population, so n minus 1 observation will be available for the sampling. Okay, and again for the third draw, 2 observations will be already eliminated from that population. Okay, so this is basically simple random sampling without replacement. Okay, so in some cases simple random sampling with replacement is not possible, and in that case simple random sampling without replacement is used. Okay, so for example, if we consider the blood testing, okay, if we consider an example of blood testing, in that case simple random sampling with replacement is not used. Okay, So once the blood is taken out from your body, it can't replace back to your body basically.
प्रेजेंट को देख क्या सालो
Without
ये प्रेजेंट
replacement.
को देख क्या और बोल कि हम जा रहे हैं
Okay.
Sorry, sir. Continue this. Continue this.
Yes, yes. Okay. So in practice, in some cases, simple random sampling with replacement is not possible. Basically, so in case of blood sampling example, we can't replace back that blood in our body. It will create a problem basically. So that's what simple random sampling with replacement is not possible. And in that case, simple random sampling without replacement is used. Okay. So basically, when the sampling is destructive, okay, when the sampling is destructive, in that case, simple random sampling without replacement is used. Okay? For example, if you are working in, let's say, DRDO or some defense institute where you are dealing with the explosives, and we want to study the explosive power of the explosives. So in that case, we need to destroy that explosive. Basically, if you are testing the bomb, you need to check whether it is actually working or not. So you need to destroy that. Okay. So once it is destroyed, we can't use that bomb again for a testing. So in that case, simple random sampling without replacement is used. Okay. So that is basically difference between simple random sampling with replacement and without replacement. Is it okay or I'm going very fast? Okay.
Okay, sir.
fine sir okay sir
Okay. Okay. Fine. Good.
Okay, okay.
Yeah. Now, this simple random sampling with replacement and without replacement, both the techniques are useful when the population is homogeneous. Now, the population is homogeneous means when you are like dealing with the observations, we are very close to each other. So if, let's say, if in case of income, you may treat that middle class as a one homogeneous group, okay, or a group of rich people as a homogeneous group, whereas group of poor people as a homogeneous group, because more or less they are in the same category. Okay, but so if you are studying this three groups at a time, then there will be a difference. Okay, there will be a difference in the basically. So if your population is divided into some groups, okay, divided into some groups. So let me just denote it by some, let's say this is a group of poor peoples who are below poverty line, So this is the middle class, or we can say lower middle class. Okay, so upper middle class, and group of rich people. Okay. Now, in that case, that entire population is not homogeneous. And if you are collecting a data from any of this subgroup, and you are going to talk about this entire population, in that case, your conclusions may not be right. Okay. So to make sure that you are getting data from all these groups, we need to use some other sampling scheme apart from that simple random sampling with replacement and without replacement. Okay. So here the term stratified random sampling come into picture. Okay. The entire population is divided into the homogeneous subgroups. Okay. Like here, I have divided the group of peoples into rich people, below poverty line people, lower middle class, and upper middle class. And you have to select a sample from each group. Let's say small n1 number of observations from rich people, small n2 number of observations from lower middle class group, small n3 number of people from the upper middle class, small n4 number of people from below poverty line group. Okay, and that your total sample size n will be this n1 plus n2 plus n3 plus n4. Okay, and based on that n observations, you can apply statistical techniques and draw some conclusion. Okay, so this is what basically happened in real life. Okay, so in very rare scenario, we are getting that homogeneous population. Okay, there are always some groups. Even if we consider that politics case. Okay, even if you go through some reports and analysis, you might see that some particular group of people will always vote for some particular party. Okay, so there are some groups, inherent groups in the population. So you need to consider these groups in the population to draw a random sample. Otherwise, your sample will not be appropriate sample, and it will create a problem in your analysis. Okay, in your conclusions, basically, your interpretations will be wrong. Okay, so that's why stratified random sampling is come into picture. So basically, we are dividing the population into some homogeneous subgroups, and we are drawing a random sample from each subgroup. Okay. See, yes.
So
Yes.
does it matter that what is the size of the group? Probably the middle class is bigger or low middle class is smaller. Will it matter?
Yes, it matters. It matters. Okay, so that we are going to see. Yeah, it is not part of this lecture, but still I'm explaining it. In case of stratified random sampling, there are different methods to draw a random sample. Okay, again, so in stratified random sampling, so in this case, first we are considering the proportional allocation method. So in this proportional allocation method, basically sample size of ith subgroup Ni is directly proportional to population size of ith subgroup. Okay, so that is what that proportional allocation coming to picture. So sample size of ith subgroup is directly proportional to population size of that ith subgroup. Okay, so in this case, that Ni is equals to n into small capital Ni upon n. So this is how we are deriving that Ni, that sample size of ith subgroup. So population size of that subgroup is important in this case. Okay? So this is the very basic allocation method, proportional allocation. And in the second case, we are also considering that variability present in that group. Okay, so variability may changes as subgroup changes. Okay, so that the next allocation is the Neyman's allocation, and it is that sample size of ith subgroup is directly proportional to Ni, that is population size of ith subgroup, into variability of ith group, that is denoted by Si. Okay, so these formulas are a little bit complicated, so I'm not going into the formulas right now, but this is how, if you are interested in this, you can actually go and check. Okay, so this will help you to design your sample surveys. So is it okay?
Yes, sir. Yes.
Okay. Yeah. So, and the rest of the sampling scheme, I'm not going to explain, because now we have just completed half an hour of our session, and we want to do some analysis with the help of our software. Okay? So systematic sampling is one more sampling scheme, but it is not commonly used by the social science people. Cluster sampling and two-stage sampling, you can check. This might be useful for social science people. So cluster sampling, so there are some groups, inherent groups in the population, and that entire group can be selected for the sampling. Okay, So that can be done. So you can go and check this cluster sampling. So lot of material is available online. So I'm not much worried about that content, but we will just focus on the applicability of the technique. So yeah, this is the crucial part in the designing this sample surveys, sample size determination problem. Okay, so basically when we are uh, collecting the data through some surveys, through some questionnaires, we need to think about our sample size. How much sample should I take so that our results will be appropriate, statistically appropriate? Okay. So you might conducting surveys very frequently for your research purposes. In that case, we need to fix the sample size. Okay. So right now, in even our statistics students are not worried about that sample size determination. Okay, but one should always determine the sample size. Okay, and then collect that much amount of data, minimum that much amount of data, and then analyze it. Okay, so here we will see two formulas. Okay, one is infinite population. So infinite population means when the population size is very large. Okay. When the population size, let's say in 10,000, 20,000, 30,000, or in lakhs or crores, in that case, we may use this formula. Okay. N0, N0 is equals to Z square into P into 1 minus P upon E square. Okay. So where this N0 is the required sample size. Okay, and this is basically the for the proportion. So I haven't included the sample size determination for sample mean. So I have just focusing on the proportion because most of the questionnaires are dealing with that attributes. Okay, so that's why I'm just adding the sample size determination problem for proportions only. Okay, so N0 is the required sample size. Z is the cutoff value of standard normal for given level of significance. Okay, so do not worry about this Z. Okay, so this Z is basically depends on that level of significance. And what is level of significance? Level of significance is basically committing a type of error. Okay, committing an error in the testing of hypothesis. Okay, so usually in practice we are fixing it to 0.05. Okay, that is 5% error we are fixing at the beginning of the testing problem. Okay, and for this 5% level of significance, that Z is taking value 1.96. So in most of the cases, we are taking the value of Z as a 1.96 because we are fixing the level of significance at the beginning, which is 0.05. Okay? So as level of significance changes, the value of Z changes. Okay? So the online tables are available for this. Okay, so you can go and check the online tables as well if you want to change this level of significance. Basically, it is a type of error, okay, one type of error. So, and I don't want to go into the technical terms, so I'm not explaining it. So just fix it to 0.05. You will get Z is equals to 1.96. And this P is the estimated proportion of characteristics under study. Okay. So for example, if you are studying that multidimensional poverty, in that case, your initial guess that 15% population is facing that multidimensional poverty. Okay, so in that case, your P will be proportion of people who are facing the multidimensional poverty will be 0.15. Okay, so that is P, and 1 minus P will be 0.85. Okay, and you can use this to compute the N. Okay? So as a user of this formula, you just need to put this P appropriately. You have to just, you need to guess this P appropriately, so that your sample size will determined appropriately. If this P it changes, if P changes, your sample size will change. Okay.
Sir, please explain P again.
Yeah, basically this P is the proportion of characteristic under study. Okay. And if I am studying that, let's say multidimensional poverty, okay, multidimensional poverty, let's say for Pune city, okay, and my initial guess is that 15% population in the Pune city is facing that multidimensional poverty. Okay, so this is the out of 100 people, 15%, sorry, 15 people are facing that multidimensional poverty. Okay, so the proportion will be 0.15. Is it okay?
Sir, this is our hypothesis.
No, not the hypothesis. This is just the initial guess. This is just the initial guess to determine the sample size.
So on what basis we have taken this 15?
Yeah, right. So it may be depend on the previous studies. Okay, so that P might be chosen based on the previous studies, which might be conducted for all over India level, or it might be for the some other cities. Okay, which is similar to Pune city. Okay, is it okay?
Sir, suppose
Yes.
we are studying the proportion of say income or the low level incomes of the sample. How do we get to know the percentage? What is the percentage then?
Yeah, basically a lot of people are working on the same area. Okay, so at the you have in the literature review, in the literature review, you might observe some research papers which are dealing with the same kind of research. Okay, so you can, if Pune is the metro city, you may compare Pune with some other metro city, and if that study is happened for that particular metro city, you can use their P, estimated value of P, to estimate the sample size. Okay, so if we don't know anything about that proportion of people, if we don't know anything about that proportion of the people, you can set that P as a 50%. Okay, so P, we can, sorry, yeah, wait a minute. So if that you are conducting the new research, and so we don't know about that P, proportion of people who are satisfying certain characteristics, you can simply fix this P as a 0.5. Okay, so the sample size is maximum for this 0.5. Okay, that n naught which we are getting over here will get the maximum for this P is equals to 0.5. So that n naught will be large. But if you know that you are in the population 15% population is satisfying only that characteristic under study, you can use that information over here, and you can reduce your sample size. Okay, is it okay, or is it confusing?
Yes, sir.
Okay, yeah. So the idea is, if you don't know about that entire population, so what is the proportion of the people who are satisfying certain characteristic, use P is equals to 0.5. So it is kind of, we are giving the equal opportunity. Okay, so
Sir, can you
unbiased.
explain Z?
Yes, Z is basically it is depends on this level of significance. Okay, let me just use another blank slide. Yeah, see, level of significance. So to get the value of Z, we need to understand that level of significance. Basically, this level of significance is probability of committing type 1 error. So in testing, we are committing type 1 error and type 2 error. And what is type 1 error? It is probability of rejecting the null hypothesis, when null hypothesis is actually true. Okay, so we know that in population null hypothesis is true, but there are some cases in which maybe our data is not appropriate, or data is not able to tell us or represent the population appropriately. In that case, we may end up with wrong conclusions, okay, or we may end up with getting wrong decisions. Okay, so we are rejecting the null hypothesis when null hypothesis is actually true. That is the type 1 error, and its probability is usually we are fixing it as a 0.05, that is 5%. Okay, so it means if we are repeating the experiment 100 times, if we are repeating the same experiment 100 times, out of 100 cases, in 5 cases, we may end up with some wrong conclusion. We may end up with rejecting H0 when it is true. Okay, so this is the kind of statistical error. Okay, error in the testing. Okay, so this is the level of significance, and in the in case of proportions, that proportion test statistic, Z test statistic is standard error of that we had is following normal distribution. So I'm not going into these details now, but that normal distribution will come into picture, or it is also called as Gaussian distribution. Okay, and in that Gaussian distribution, it is we all know it is symmetric distribution. Yeah, I'm not able to draw. There is some problem with my pen. So it is a symmetric distribution. Okay, and this region at the tail part is actually very rarely occurring. Okay. Tail part means on x-axis we are having that statistic values, this z values. On y-axis we are having that probability. Okay. Probability. So basically in the tail part is we are getting very less probability for the normal distribution. Okay. So this is basically a rejection region in which we are rejecting the null hypothesis. Okay. We are rejecting our null hypothesis. So, and this is the probability of this rejection region is set up as alpha. Okay. And this alpha is nothing but the level of significance, that is probability of committing type 1 error. Okay. So that is the actual idea of level of significance, and for the given level of significance, we are finding the value of z. So this threshold value of z, okay, if any value of z is greater than this value or less than this value, z alpha by 2 we are calling it as. Okay. So if any value less than this minus z alpha by 2 and greater than plus z alpha by 2, in that case we are going to reject H0, and this value of z is coming over here. Okay. So in this slide, okay. But please do not worry about this z value. There are normal probability tables. Okay, so if time permits, we will revisit this, and I will tell you that different values of z for different values of alpha. Okay, how to try different values of z for the different values of alpha. I will show you that table as well. Okay, is it okay? This is little bit
Yes, sir.
technical. I want to keep things
Yes, sir.
yeah. Yeah. So here you can fix uh, uh,
सर वो आवाज नहीं आ रही है. Maybe you're on mute.
Sir, your voice is not audible. Shantaram, sir. Shantaram sir.
Sir. Yes. Am I audible?
Now you audible, sir, but
Yes.
your voice is very low.
Okay, let me just increase the audio level. Is it okay?
Is it okay, sir?
Okay. Okay. Fine. Now, yeah, let me just go back. Yeah. So Z we are fixing, P we are fixing, that E, margin of error. Okay. This margin of error is nothing but the sampling error. Okay. Sampling error. So error in the sampling. How much error we are expecting in our sample. Okay, that is the margin of the error. So we may fix this as well. Okay, so it is depends on researcher how much error is there in your sampling. So usually people fix this to 0.05, and if you are increasing if you are allowing more error in the sample, your sample size will decrease. Okay, so but your results will not be accurate. Okay? Your results will not be accurate. So in that case, we usually fix this error, margin of error, as 5% or 10%. Okay. So this is the formula which we are using for the infinite population. And for finite population, first we need to compute this n naught, okay, which is for the infinite population. And then by using that knowledge of n means population size. Okay, we can compute the sample size for the finite population, which with n number of observations. Okay, so we will do this exercise in our software. So basically, we can use calculator itself. Okay, no need of our software. But since yeah, I will use R as a calculator, so that we will start with basics in R.
So what? How is n not calculated? Small
N naught is sample size for infinite population. Okay, and and we are using the knowledge of n over here, so that our sample size will reduce if the population size is finite. Okay, it is very simple formula. Both the formulas are very simple. We will yeah, I will show you within a minute. Okay? So before that, I just want to complete with this headline. So be careful while sampling. Okay, if your sample is good, you will get a good results. Otherwise, you will get horrible results. Okay, so this is basically headline of the Chicago Daily Tribune, and I guess it is 1948 US presidential election. Okay, and this person holding this newspaper is actually Truman. Okay, who was the who was elected as president in the 1948 US presidential election. Okay, so actually, see this headline. That headline is Dewey defeats Truman. Okay, so it means Dewey won that election. Okay, but actually it was in the reverse way, that Truman won the election. Okay, and why this headline is getting wrong? Okay, basically current, if we see the current media, basically electronic media, that competition is very huge, okay, amongst them. Okay, so they are always give us breaking news. Okay, every time if we open the news channels, they are always giving us some breaking news. Okay, because of the competition. Okay, this competition was there in the that print media in 90s, in 20th century. Okay, so that Chicago Tribune actually went to one person who is actually collecting some data from people, and it is making some opinion about the elections, and that person actually predicted correctly in last few consecutive elections. Okay, that this person will win the elections. Okay, and and that the editors of that Chicago Tribune believes that person, and uh, gives this headline. Okay, so the data collection method by this person is actually new at that time. New at that time means in the previous elections, he actually used to meet the people in gardens and in restaurants and in some other places, and record their opinion about the presidential election or any other election in the US. Okay. But in 1948, after the innovation of telephone, that person is decided, why should I meet people in the gardens, restaurants, and in other places? Why should I waste my time? So instead of that, that person used his telephone to collect the data. Okay, and at that time, telephone was new, okay, very new, and very rich people are having the telephone. Okay, that poor people in the society were not using the telephone at that time. So he just check his telephone directory, select some phone numbers randomly, and call these people and recorded their opinion. Okay, and based on their opinion, he make the prediction that Dewey will win the this presidential elections. Okay, but see that data collected from the telephone with the help of telephone is not actually representing the entire population. It is just representing the opinion of rich people. That data is not representing the opinion of poor people or middle class people. Okay, and that's what that person end up with wrong conclusion, and also the headline of Chicago Tribune was wrong. Okay, so this is a very good example of sampling. If if your sample is not good enough, if your sample is not representing your population completely, in that case we may end up with some wrong conclusions. Okay, and if in some cases these conclusions may be serious, lead to be some serious issues. Okay, so this is the actually very good example of sampling error. Okay, hope you enjoyed this example. So yeah, you can check this example on Wikipedia or other sources as well. This is available. Okay, so yeah, we will quickly go through this sample size determination in R. Let me just show you. Okay, so are you able to see that software window?
Yes, sir.
Okay, okay. So yeah. Sample size for infinite population. Let me just show you. Yes, infinite population. Okay, so n naught is equals to z square into that some p. Okay, so I'm just typing the formula p into 1 minus p. Okay? 1 minus p divided by this whole term divided by e square, that is error. Okay? E raised to something, e square. Okay? So we need to fix that z and p at the beginning. Okay? So z for 5% level of significance, z value is 1.96. Okay? And p we can consider, let me now I don't know the proportion of people in the population who are satisfying certain characteristics, so I'm taking it as a 0.5. Okay, and error, this is the sampling error, e is the sampling error, so I'm fixing it to 0.05. Okay, so error which I'm allowing in my sample, so this is n naught given something, let me just print it. Okay, so
Sir,
yes.
one small request. Please, can you also share the source code right now or later on?
Okay. I will save this document then. Yeah.
Yes, thank you, sir.
Yeah. See, for this values, sample size is getting 384. Okay, approximately you need to select 384 observations in your sample so that you will get fairly good results. Okay, if you are selecting more than this, it will be very good, because more the data, more the accurate will be your predictions. Okay, so that is the story of statistics. So minimum you need this many observations in your sample if you are considering the infinite population. Okay, now if for the finite population, for the finite population, the formula is little bit different. N is equals to, yeah, I need to check that formula where it is. Yeah, yes, the formula is N naught. So N naught in the numerator divided by 1 plus again N naught minus 1, N naught minus 1 divided by capital N. Okay, and this capital N is the population size. Okay, if I fix it to 4,000, let's say, so this is the population size. If we are fixing this to, yeah, N naught is N0, I have used N0 over there. Yeah, so see, now because I know if my population size is 4,000, so I have used that knowledge over here and reduces my sample size. Okay, so the knowledge of N is not not required, or it is not compulsory, but if you know that population size, that required sample size will be reduced. Okay, so that even if you are with small data, you will get good results. Okay, but if we don't know that capital N, that is population size, it is okay, you can compute that sample size by using that infinite population formula. Okay, as error changes, let me allow some high value of error in my data, sampling error. See, my population size will reduce, sorry, sample size will reduce. Okay, because I'm now committing that 15% error in my sampling. Okay, 15% error in my sampling. So when the error increases, your sample size will lower down. Okay, so we are always trying to fix this error to 0.05, or mostly it is not more than that 0.1. Okay, so usually people are fixing it to 0.05, 5% error. Okay, so that there should not be much error in the sampling. Okay, is it okay? So even I'm using R over here, but you can do this exercise on calculator as well. Formula is very simple. Okay. Yes, so this is the about the sample size. So we have completed I guess 1 hour. There's still many things pending. So are you with me so far? Hello?
Yes, sir.
Yes, sir.
Okay, okay, fine. Yeah. Now let me go back to the presentation. Yeah. Yeah, data types and measurement scales. So as a statistic student, so I found this very, very important for all of us. Okay, data types is the very crucial part. If if you know the different data types and measurement scale, you will be able to apply different statistical techniques. Okay, so different data types and measurement scale is the very crucial steps in the statistics. Okay, so yes, so there are two types of data mainly. One is the categorical data and numerical data. Okay, categorical data is the data which we can't represent with the help of numbers. For example, our blood groups. Okay, blood groups. So we can't convert this into numbers. Even if we convert it into numbers, that number will not have that meaning of numbers. Okay, it will be just used as a label. Okay, so that is what the categorical data. Blood group. Gender. Okay. Gender is another example of the categorical data where either male or female. Okay. So this is again some information, but which is not in terms of numbers. Okay. For example, nationality. Nationality. Again, this is some information which we can't convert into the numbers. Okay. So yes, this is the categorical data. Okay. And all these are variables which are changing person to person. Okay. Then in numerical information, again, this numerical information can be divided into two categories. Okay. Numeric data. It may be a discrete data or continuous data. Okay. Numerical information. It might be a discrete information or continuous information. Continuous information. For example, in case of discrete case, that let's say number of accidents. Number of accidents. Okay. So it will be some number 0, 1, 2, so on. Okay. And in case of continuous variable, we might consider, for example, let height of a person. Height of a person. So it is height is changing person to person, and it will take value, any value in the interval. Let's say in the interval of 140 centimeter to 190 centimeter. Okay. So it can take any value. Okay. So it is a continuous variable. So height may be 145.5 centimeter. Okay. It depends on that accuracy of that instrument. With the help of we are measuring that height or length. 180.55 centimeter. Okay. So again, if you are measuring that very precise instrument, then it might be give us 180.553 centimeter. Okay. So it can take any value in that interval. So that is the continuous numerical data. And if there is a counting process, okay, there is a number of students attending the lectures, number of accidents are happening, okay, number of people satisfying certain characteristics. So it will be in the discrete case. So this will be the discrete numerical information if there is a counting process. Okay. Now that 4 different scales of measurements are important. Okay. These 4 different scales of measurements are nominal scale of measurement, ordinal scale of measurement, and interval scale of measurement, and ratio scale of measurement. These 4 scales of measurements are very, very important to understand the different statistical use of different statistical techniques in the data analysis. Okay. In the nominal scale of measurement, sorry. In case of nominal scale of measurement, that observations are just named categories. Okay, observations are just named categories. Okay, so for example, blood group. Okay, blood groups are just labels. Okay, A plus, A positive, O blood group, B negative blood group. Okay, B negative blood group. These are just labels to that groups. We can't arrange these blood groups. Okay, we can't say that the people who are having O blood group is the superior than the people who are having A plus, A positive blood group. Okay, we can't make such a decision. Okay, even if we consider gender, again, it is just a named category. Okay, we can't say that the males are superior than females. No, we can't make such conclusions. Okay, so these are just named categories. Okay? So can you give any example of named category? which is measured on the nominal scale? Yes.
So names.
Yes. Names is the information which is on the nominal scale.
Sir, data according to month wise.
Yeah, months will be just labels, right?
Sex,
Yeah,
gender.
gender, sex, yeah, it is there. Nationality, we can't say that that people from US are more superior than us. No. Okay. Nationality is there. Okay. So residence, okay, these are the named categories. Even see
Occupation.
this
Your
yes,
economic status like APL, BPL.
yes, that is also the named categories only. PIN number, okay, pin code number, area pin code number. We can't say that 411030 people are superior than some other people. No. Okay. So this area pin code is again a label, just a named category. Okay. It is, even though it is a number, it is just a named categories to identify a certain area. Okay. Yes. Ordinal scale of measurements is the scale of measurement on which we are able to arrange that categories. Okay. We are able to arrange that categories. For example, result of the students. Okay. Result of the students in, let's say, first class with distinction. So distinction. Okay. Second class. So we are actually able to arrange this. Okay. So distinction means that student is getting more than 70% marks. Okay. So getting marks more than that first class. Okay. First class. Again, that first class student will get more marks than this student who got the second class. So we are able to arrange this data. Okay. So the data measured on ordinal scale can be arranged. Okay. So for example, in these surveys, we are mostly, our data is on the ordinal scale. Okay. For example, taste of a ice cream. Okay. So I'm giving some response, some options to the participants. Okay. So for example, very bad, good, very good, bad, or neutral. Okay. So these responses can be arranged. Okay. According to the quality. Very good might be at the top, then good, then neutral, then bad, then very bad. Okay. So this is basically the ordinal scale. Okay. And according to this scales of measurements, statistical techniques will change. Okay. Statistical techniques to analyze the data will change. Okay. Interval scale is the scale used to record the numeric data. Okay. So interval scale is used to record the numeric data, but the problem with this scale is that 0 point is not arbitrary. 0 point is arbitrary. Okay. It is not a true zero. Okay. It is not a true zero. So if we consider that temperature scale in degrees Celsius. Okay, temperature scale in degrees Celsius. So at some places, minus 5 degree Celsius temperature is there. Okay, so minus 5 degree Celsius temperature does not mean that the heat is absent at that place. Okay, 0 degree Celsius does not mean that heat is absent at that place. Okay, so obviously 0 is not a true zero. That 0 is arbitrary 0. So basically when your data is starting from some negative numbers, and 0 is at the middle of that sequence, in that case that 0 point is not a true 0. It is arbitrary 0. Okay. So yeah, one example of this interval scale is MCQ type exam with negative marking. Okay, MCQ type exam with negative marking. So let's say there are 10 MCQs. Okay, 10 MCQs in an MCQ type exam. So, and that negative marking is of -1. Okay, if that any answer is wrong, so my -1 mark will get added in the total marks. Okay, so possible marks for the students will be either all the answers are correct. In that case, that student will get 10 marks. Obviously, the MCQ type with 1 marks each. 1 mark each. Okay. So maximum marks are 10 marks. And what will be the minimum possible value of the total marks? If you are considering, if the answer is wrong, we will directly subtract 1 from the total.
Minus
Yes?
10.
Yeah,
Minus
minus 10. Yeah, right, minus 10. So if any student gets 0 marks, does it mean that all the answers given by that students are wrong?
No.
No, right. So in this case, this 0 is not a true 0. Actually, that student gave 5 correct answers out of the 10 questions. Okay? So here 0 point is arbitrary 0. It is not true 0. So what is the true 0 for this data? -10 will be the true 0 for this data. If we set our 0 to minus 0 to this -10, in that case, that will be the true 0. Okay. But if you are considering this scale, then this is the interval scale. Okay. That 0 is not the true 0. Okay. So hope you got the difference. And in ratio scale of measurement, 0 is actually 0. Okay. 0 is true 0. Okay. So if we consider height, weight, and length, okay, these are the variables: height, weight, length, width. Okay, so these are actually starting with the true 0. Okay, so we can't see height in the negative, weight in the negative. Okay, it always starts with the 0. Even if we consider that amoeba, very famous species, even its weight will be greater than 0. Okay, so it will not be a negative. Okay, that is the point. That is the difference between that ratio scale and interval scale. Okay, so as I already said, depends on these different scales of measurements, your statistical techniques will change. Okay, statistical techniques will change. And let me show you one table directly. See this summary. Okay. In this summary, this if the data or variable are measured on that nominal scale, we are able to represent that data with the pie diagram, bar plot, or line chart. Okay. If and we are simply do the counting process over there. We simply count the observations. Okay. So for example, if we consider blood group, okay, it is measured on the nominal scale. It is just a named category. We just count that how many observations in the data are from O positive blood group. How many observations are there in the data from, let's say, A positive blood group. Okay. We can't add or subtract these observations. Okay. So that is the drawback of nominal scale. Okay. And we can represent this nominal scale data with the frequencies with the help of proportion, percentage, or mode. Okay. So this is the summary statistics which we are using to represent this nominal scale data. Okay. If the data is measured on the ordinal scale, variable is measured on the ordinal scale. So again, this ordinal scale is used to record the categorical data. Okay. We are able to do the counting and ordering. Okay. We are able to arrange the observations in the ascending or descending order if it is measured on the ordinal scale. Okay. And if it is measured on the ordinal scale, we can compute mean, sorry, not mean, median, mode, and percentiles and interquartile range. Okay. There are many more, but I have just added very few. Okay. So this is again there are some limitations on this ordinal scale as well. Okay. See, we are not able to add two observations. Okay. For example, taste of a ice cream. Okay, taste of a ice cream. It is very good, good, sorry, good, bad, very bad. Okay. So we can't actually add these observations, right? And we can't divide these observations by numbers. Okay. Even if we represent it by numbers, so let's say very good is 1, good is 2, bad is 3, and very bad as denoted by 4. So these numbers does not have any meaning. Okay. So if we add all these numbers and divide it by some number, it will be a meaningless number. Okay. So it does not have any meaning. Okay. So we can't do the addition, subtraction, division, and multiplication for the data recorded on nominal scale and ordinal scale. Okay. And see, there are even the summary statistics are different. Okay. Summary statistics are different. Interval scale is used to record the numeric data. Interval and ratio scale are used to record the numeric data, and box plot, histogram, scatter plot, frequency curves are used to represent such a numeric data. Okay. On the numeric data, if that numeric data is measured on that interval scale, we are able to perform addition and subtraction, but we can't do the multiplication and division. Okay. So multiplication and division is not allowed if that data is measured on that interval scale. That is just because of 0 is not true 0 on the interval scale. Okay. So we can do the addition and subtraction, and we are not able to do the multiplication and division if the data is measured on interval scale. Okay. And these are the summary statistics which we will be able to perform on the data measured on interval scale. Okay. Ratio scale, this is the ideal scale. Okay. We are able to perform all kind of numeric arithmetic operations on it. Okay. If the data is measured on ratio scale, addition, multiplication, division, and subtraction, all four arithmetic operations are allowed on the data measured on the ratio scale, and it covers all the techniques, all the statistical techniques. Okay. So if your data is measured on ratio scale, it is very ideal case. Okay. Most of the data in social sciences is recorded on the ordinal scale. Okay. Most of the data. Okay. So for that purpose, we will see some statistical techniques in the next half of this session. So now I just want to show you some diagrams and graphs for the nominal scale and ordinal scale. Okay. So have you installed R software?
Yes, sir.
Okay. So if you are ready with R software, we will try.
Yes, sir.
Yes, sir. Yes, sir.
Yeah, fine, good, very good, sir. So
Hello, Shantaram, sir.
yes, sir.
Some problems of participations are download software, sir. Can you again explain the how to download the R software and how to R Studio?
Yes, sir. Sure.
Okay, thank you, sir. Thank you for your
Yeah.
purpose.
I'm just it's moving to some other screen. Yeah. So to download R software or R Studio, you can just go to the Chrome window and search R for Windows. Mostly we are using the Windows. So Windows.
Sir,
R
R Studio is also the same thing.
Yes, R Studio is also the same thing. In fact, R Studio is more user friendly.
Okay, sir, I downloaded R Studio.
Okay, but to open the R Studio, we need R software. So maybe you are facing some problems with R Studio. Am I right? So you will not be able to open unless and until you have installed it R software on your computer. Okay.
Okay.
So you have to just search R for Windows and download it. Download R for Windows. Very first tab. It will take some time. So setup is around like 79 megabytes. So you click on that download R 4.3.2 for Windows. Okay. It will take some time. Yeah. For me, it is downloaded, and let me just click on that downloaded setup. Yes. Once you click on that downloaded setup, are you able to see that window? Do you want to allow this app to make changes on
Yes,
your
sir.
computer? Okay. So I'm allowing to make some changes on my device. So yes. Select the appropriate language. Yeah. I'm closing one setup. Yeah. Select the appropriate language. Okay. So you have to just click on next button. Okay. Keep on clicking on that next button. Accept the default one. Okay. Next, next, and setup will be installed on your computer. It will take a few minutes. Yeah, just click on the finish button, and then you are ready with the R software. It's very easy to install R. Is it okay?
Sir.
Yeah, fine. So now, yeah, I have already shared 2 days data sets with you. Actually, while conducting any kind of survey, if you are not aware of statistical techniques which you are going to use, then please consult with the a person from statistics, because so it might happen that you may end up with some data form which will be hectic for a statistician. Okay, so for example, yes, yes.
Sir, one question I would like to ask that there's a option of startup options. So they are asking yes or no. So should we accept it for the customization or like
No.
are
Accept default one, ma'am.
okay, sir.
Go for the default one.
Okay, sir.
See, this is the data of academic stress. This data I haven't shared with you, but in this data set, see, they are asking some questions to the students. Okay, and while asking the question, they are giving some options. Okay, so this is basically a multiple select question. Okay, and it is very difficult to deal with such a data. Okay, it requires lot of data cleaning and data pre-processing. Okay, so when such a data come to the statistician, it took 50% of the time on the data pre-processing and data cleaning. Okay, so while collecting the data, or before collecting the data, or before designing the questionnaire, so if you are not good at statistics, please communicate with the person from statistics, so that that data will be collected in the appropriate manner and your job will be done quickly. Okay, so if data is appropriately collected, in that case it hardly took 5 to 6 hours for a statistician to analyze the data. Okay, but if data is not in a proper format, then it needs lot of efforts to convert that data into the appropriate format, so that statistical techniques can be applied. Sometimes it is even the data is not matching with the objectives set up by the investigator. Okay, so that problem is the very serious one, and that person has spent 4 or 5 years in the PhD, but did not get anything out of it, and at the last moment they want results. Okay, so it will be very difficult for a statistician to extract the information from kind of garbage. Okay, so before collecting data, before designing the questionnaire, if you are not good at uh, understanding the statistical techniques, I'm not saying that mm, applying the statistical techniques, but if you are not understanding the statistical techniques properly, in that case, please consult with the statistician. Okay, so so this data actually need lot of efforts to convert in the appropriate format. Okay? So it's very big character strings and all that stuff. Okay, this is just an example. Okay, yeah, this is the data. Yeah, academic stress, yeah, BDD, no, BDD original. Yeah, this data I have shared with you, but I have shared, I guess, original data. Let me just open that original data. Statistical methods, original. Yeah, so this is the data with all of us. Now, now, see, I want to represent this data with some graphical techniques. Okay, some graphical techniques. So basically, I want to check, let's say, so if we consider that gender column, okay, this gender column is having two values, okay, either male or female, or I want to check faculty wise responses from the students. Okay. So this data, I would like to represent this data in some with the help of some diagram. Okay. So first check the scale on which that variable is measured. Okay, so see the variable faculty. What do you think the underlying measurement scale for the variable faculty?
Nominal.
Yes, absolutely right. It is the nominal scale. We can't actually arrange the observations, right? So we can't say that science people are superior than the humanities people. No, we can't say. Okay. So this is the data measured on the nominal scale. So we may represent this data with the help of some pie diagram or bar diagram. Okay. So first, I need to import this data set in the software. So are you ready with our software? Just
Yes, sir.
respond me in the chat box. So if you are ready, please let me know in the chat box. Yes. Okay. Fine. So we will, yeah, good. So I'm trying to read this data set in the R software. So here, importing the data in R. Data in R. So this is just a comment. Okay, this is just a comment. No need to copy it. Okay. So whenever you would like to add some text in the codes, start the text always with hashtag. Hashtag is basically, it denotes that you have added a comment and you haven't wrote that code. Okay. So now the command is simply read.csv. Okay. Read.csv, and output of this read.csv I'm storing in, let's say, D. Okay. So instead of D, you can use any letter. Okay, so I'm using that, let's say, D1. It's okay, completely okay. Okay, there are some rules of defining these names, but I'm not explaining the rules. But you can start with any letter. Okay, you can't use special characters, or you can't start with that name with the numbers. Okay, so you can use any letters. So I'm using, let's say, DD. Fine. Read.csv, and inside this read.csv, I'm typing file.choose. file dot choose. Okay, file dot choose, and pressing the Control R. I'm on the same line. See, my cursor is blinking on the same line. Okay, so this window is called as editor window. Okay, so you can select this window by using file. Click on the file, new script. That editor window will come into picture. Okay, so editor window, and this window where the name is given as R console. This is basically output window. Okay, so now I'm running this line. So I'm on that line. My cursor is blinking on that line. So just pressing Control R. Press the Control and R button. It will open a place. Okay, so you have to select the data file. So currently my data file is available on the desktop, and on desktop there is a folder statistical methods. Okay, I have stored that file in the folder statistical method, which is available on the desktop. Okay, so once you locate that folder, click on the file which you want to read. Okay, so yes, so I have just double clicked on that file, and that file is get read in R. Okay, so yeah, now you can view the data set in R. Okay, so view DDT. Okay, see, so data is imported, and we are able to see that data. Okay, and this V in this command view is capital. Okay, just V is capital, remaining command is in small letters. Okay, so shall I share this code with you in the chat
Yes, sir.
box, so that you can easily copy paste it, and
Yes, sir.
will be able to check whether we are going correctly or not. Okay, so yes, just let me know once you are able to view the data set. So you have to select the appropriate folder where you have stored your data. It might be stored on your desktop. It might be available in your downloads. It might be available in your documents.
So which file we have chosen?
That BDD original, ma'am.
Original one. Okay.
BDD original. Yes. Anyone ready with the data set? Yes, very good, sir. So Yogesh sir is ready with the data set, able to view the data set in R. Yes, sir, error आ रहा है. अच्छा मैम, you can. So
Sir,
what?
can you please explain it
Sir,
again?
can you please re-show it once again? The
Yes.
code is not working, sir.
Yeah. Okay. 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 So, sir, where is your file located?
It's on desktop.
Okay, it is on desktop. See, I'm storing my file in the DD. Okay. So, command is read.csv. Okay, read.csv simple brackets. Okay, inside that simple brackets, you have to just type file dot choose. Okay, again bracket complete. Okay, so after typing this, just be present on that line. So my cursor is blinking on the same line. Press Control R button. It will open the new window. So you can select the folder or path where your file is available. So currently my file is available on the desktop, and on desktop there is a folder called statistical methods. Okay. So I'm selecting that folder. After selecting that folder, so I can see my file BDD original. So I'm double clicking or just selecting that file and clicking on the open. Okay. So that file will be read, and so after typing view, we will get that file. Okay. We will be able to see that file. Okay. So code is already available with you in the chat box. You can check that code, copy that code, and just paste it in your console editor window.
So after pasting this code, we have to say Control R
Yes, Control R, Control plus R. Yeah.
after the bracket.
Yes, after the bracket, or even if you at any place on that line, it doesn't matter.
Yes, sir. Now it's working.
Okay, sir. Very good. Very good. Yes.
Sir,
Yes.
once I did, it was visible, but now it is not working. I mean, I don't know why.
Okay, fine, ma'am. You can just click on that view button again. You can run that view line. Control R. Press Control R. Is it coming?
No, sir.
Okay.
Sir, in some cases, right, we have to press the enter, sir. I also tried the Control plus R. It's not working. But if I press the enter, the automatic link is getting open, sir.
Okay. Okay. So, ma'am, you can click on Windows. Okay. Windows.
Sir, when I pasted your link, dd is equals to read.csv file, then automatically it came in the same manner as it was in your screen. But now it is not working. Now, backspace is also not working, and I cannot paste it also.
Oh, so that might be just because of uh, your computer is busy with some file. So if you have opened any file and you have something going on that file, in that case it will not respond in your R software. So you might need to close that R session and reopen it.
Okay. Okay.
Or
Okay.
you can just, ma'am, just click on the Windows button, which is on the top of the R software, to Windows, and check how many windows are there. R console, untitled R editor, and third is
1 hour.
D.
It's 1 hour console only.
Okay, okay. Then fine. You can close the R session and again paste it
Okay.
in your editor. Yeah.
Okay, and sir, one more thing I want to ask, like in your screen, there are two screens visible, like
Yeah.
side by side, they are visible, but in my case, it was not visible like this.
Yes, right, ma'am. So you have to
Why?
select. So basically, R shows only console window. So you have to pick that editor window from file. To check that file button, click on file, and select new script. It will
File, new script.
new script. It will open the editor file.
Yes, sir.
Yeah. On that editor file, you can write your code, and you can press Control R button so that you will get the output in the console window. Okay.
Okay.
Yeah. See, now I just want to check names of this data. Okay. Different variables in this data. So I'm simply typing names command, names of dataset DD. Okay. See, it gives us some variable names which are present in the data set. Okay. So yes, so names command, you can check the variable names in the data set. Okay, I'm pasting it. Okay. Now once you check the variable name, you have to select the variable which you want to study. Okay. See, right now I'm interested in, let's say, faculty. Okay. I'm just interested. I'm curious about that how many respondents are from arts faculty, how many respondents are from science faculty, and how many respondents are from commerce faculty. So I'm extracting that variable. Okay. So to extract the variable, you can use this dollar sign. Okay. So I'm extracting the variable from DD. So DD dollar, that variable name. Okay. So that variable name is available for me in the console window. See, I'm directly copy pasting that variable name, faculty. Okay. I'm not typing, because if you are typing the very big variable name, so then there might be some mistakes in that also. Okay. So I'm just making use of that name's output. Okay. So, and I'm storing it in some other name. So let's say I'm storing it in faculty, F for faculty. Okay. So F, I have stored that output, and see, you can check that output as well. Okay. By simply typing like this. Okay. Let me just paste this faculty. Okay. And once you get, once you're ready with that variable, you can simply use this table command. Okay. This table command, this table of F will gives us the frequency table. Okay. This is giving me the frequency table. Okay. See, and it gives us the count. Okay. So there are total 81 students are from arts faculty, 70 students from commerce faculty, and 130 students from science faculty. Okay. So this information is now available for me. Okay. So now you can represent this table or some count information to draw a pie diagram or a bar plot. Okay. So I'm storing this output of table command in some T. Okay. So let me just copy paste it in the chat box so that you can make use of it. Some error occurred. Okay. Sir, what is the problem? Satish sir?
सर डेटा नहीं आ रहा है.
Data नहीं आ रहा है. Okay. Could you please, sir, Satish sir, could you please present your screen? I'm stopping my screen.
Yes sir. Yes.
Okay. Yeah. So you can share your screen.
Sir, I am also getting the data in the Excel form. I've got it, not the way you are showing the variables. How are you showing the variables?
Okay, ma'am. You can present your screen. I will try to debug your code. Satish sir, are you presenting?
Hello sir, your presentation is not audible. Not,
Okay,
your
sir.
presentation.
Yeah. Just waiting. Yes. Sir, yeah, let me just check. What is getting wrong? Okay. So, Satish sir,
Yes sir. Yes sir.
just click on the that plus icon just below the file tab.
Yes sir.
Click on that plus button, which is just below that file name on the very top left. Top left. Yes, where it is.
Sir, same issue also.
Okay, so have you installed that? Yes, new file, sir. New file. Yes, script file. Yes. Now, sir, just simply copy paste that code which I have shared with you.
Yes sir. Yes.
Okay. So all of you can do this way.
Sir, please can you recopy and paste the code?
Sorry, ma'am.
Ma'am, can you please resend the code on the chat box?
Okay. Let me just paste it. Sir, do not type that comment. Just copy paste that code which is in the chat box. Let me just paste it again for you. Names. Okay. Control R. Okay. Yes.
Sir.
Yes, sir. DD is equals to.
Sir, is equal to does not type here.
You are not able to type that equal to. Okay.
Yes.
So there might be some problem with your keyboard. So then it will not work, sir. It will not work. There are a lot of problems. Okay. Fine, sir. It will not work in that case. We need that equal to sign. That is basically we are assigning some value to that DD. Okay.
Sir, I'm not able to get the table. I have completed everything, just table is not showing.
Table is not showing.
Yes, sir.
Ma'am, have you typed T is equals to table of F?
Yes, sir. I have typed the exactly same what you have shown here.
Just type T just below that command. See, so if you are Satish sir, it will not work in your case because you are not able to type that equal to sign.
Yes, sir. I got it. Thank you.
Okay, ma'am. Okay. Okay. Now I'm just showing the table, output of table. Yes, this is the output of table. You can see, and once you get the table, you can represent that frequency table with the pie diagram. Okay. So I'm just using the PIE command to draw a pie
So your
chart.
screen is not visible.
So your screen is not visible. Someone else is also sharing along with you.
Satish sir, have you stopped your screen sharing?
Yes, I have stopped my sharing.
Okay.
So I want to ask something.
Yes, ma'am.
Sir, I got the table. I have got the R editor also. We have to give commands in R console, right?
No, R editor. You have to type in R editor, and then you can press Control R to run that command. So if you are using R Studio, in that case, you have to press Control Enter. If you are using that R software, then you have to press Control R.
But for Control R, it is nothing is working. मतलब R console में सब कुछ वो आ रहा है जैसे आप बता रहे हैं, लेकिन आपका तो R editor में आ रहा है. मेरा R console में क्यों आ रहा है सर?
आउटपुट R कंसोल में आएगा मैम.
मतलब एडिटर में तो कुछ भी नहीं हो रहा सर, सिर्फ R कंसोल में हो रहा है. आपने जहाँ से फाइल से मुझे बताया, फाइल से ये पता नहीं कहाँ से आपने बताया था ना R एडिटर खोलने के लिए, वो साइड बाय साइड ओपन हो गया, बट उसमें कुछ आ नहीं रहा है ना, मैं उसमें कुछ लिख पा रही हूँ.
Okay, you have to type in that. That is the easiest way. You have to just file. Yes, sir.
So just now we was discussing like a control plus R is not functioning, right? So in R console, the enter is functioning.
Enter is working. Yeah.
It's like.
Yeah. Sometimes enter button will work, especially when you are typing your code in the R console. So if if you are directly typing your code in the R console, like I am typing here, let's say pi of, let's say T. Okay.
Sir, can you repeat again?
Yes. If you are typing your R codes in console window, then you have to type that enter button. Okay. By keeping your cursor on that same line. Okay. So I have typed that pi command over here in the console window. See, at the top of that window is R console. So I'm typing in the console window. I'm on the same line of R code. Just pressing that enter button. It will show me something.
So T is for what, sir?
T is for table. Table. I have stored my table in T.
Okay.
Okay. So you have to store your frequency table somewhere, and then you will be able to use it. Frequency table is not working. Sir, have you stored your variable in F? Yogesh sir?
Sir, it is giving error.
Oh. So, yeah, could you please share your screen?
So when I have typed T is equals to table bracket F, what you have sent, then after pressing enter, nothing is coming in R console. Otherwise, all the questions I got when I typed names, DD, timestamp, age, gender, etc. All the questions were there. But when I have typed T is equals to table F, then nothing is coming after enter also.
Same here, sir. Sir.
Sir, can I share my screen, sir?
Yes, yes. You can share your screen, ma'am. I'm stopping my presentation. Yeah. Yeah, it is a difficult task for me now. Even if we are able
Hello,
to
sir.
represent.
Shantaram, sir.
Yes, sir.
If you want to take a break, 5 minutes, then after the start session after 5 minutes.
Okay, okay. Those who want to take a break can take a break. Meanwhile, I will discuss the questions of participant. Okay. So,
Sir, one question. Okay, as that pi bracket T bracket, right? Actually, the code area is showing that x value must be positive.
X value must be positive. Sir,
Yeah.
could you please show your? Yes.
Can you see my screen, sir?
Yeah. Yes, ma'am.
Sir, I have got this in the upper bar.
Yeah,
And-
right. Ma'am, just go to that untitled one.
Untitled one is this one only?
Yes, ma'am.
Yes, sir.
No. This is the data window. Just click on that file which is on the left side of that DD.
This one?
No. Just below that. Just below that.
This one?
No. Just below that. Just come below. Untitled one. Yes.
Untitled one. Yes,
Yeah.
sir.
Click over there.
So this is already okay. So this
Yeah.
one.
Okay. Then untitled 3.
Untitled 3.
So where is your code? No, this is blank. Please close this window, ma'am. Untitled 3. Yeah. Basically, this is your editor window. Okay. Now type F is equals to.
So what to type, sir?
F is equals to.
F equals to.
DD.
DD.
Dollar. In capital, type faculty. Select the faculty. Yes. Press Control Enter.
Control Enter.
Yes. So it is not giving any error, means your code is running properly. Okay. Just type F over there in the editor.
F.
Press Control Enter.
After F, sir?
Yes. After F, press Control Enter. Yes. So this is the data you are having in that variable F now. Okay.
Just below that we have got, sir. This one?
Yes. This is the data which is available in the variable F. Okay. Now we want to draw a pie diagram out of it.
Okay. Yes.
So we need to convert this information into the table. Okay. So just type table. T is equals to table. Capital T is equals to table. Table. Inside simple bracket, put that F. Yes. Right. Control R.
After the bracket, sir?
No, it's okay. It will work.
Control R. Yes.
Yes. Okay. Now just below that type F, type T.
Again type T?
Yes, yes. Again type T. If you want to check the output, you
Yeah.
need to type it. Yes.
Now
Press
control enter.
Yes, again. It gives us only one value.
So control enter.
It means your previous command is not run. Okay, so just go to T is equals to table.
Yes.
Press control enter now.
Control enter.
Yes, now that command is run. Now run this control enter.
Control enter.
Yeah, yes, now you are getting the output. Okay.
Yes, sir. T
Now,
is equal to table. Yes.
yes, now you can use that PIE command, PI command. PIE. Inside that PIE, so use the simple brackets and put T in that bracket. Yes, press control enter.
Okay.
Yes.
Sir,
Yes.
may I ask the question?
Yes, ma'am.
Thank you, sir.
Sir, I'm not able to open the data.
Yes, sir, it's working.
May I
Ma'am.
share my screen, sir?
Yeah. Please share. So, have you downloaded this R software?
Yes, sir. Already downloaded. I'll just wait.
Just go to the downloaded setup. Yogesh sir, are you able to do it? Pie diagram.
Sir, I have a question. This R software and R studio are different things or one and the same thing?
Yeah, they are the same things, but R Studio is more user friendly.
Okay.
Whereas R Studio will help you some R commands when you are actually typing the command. So that facility is not available with the R software.
Okay, because some of the participants are sharing screen of R and some are sharing for R the studio. Yeah.
Right. Yeah.
Sir,
Facing
I
the
have
issue.
written the code same.
Yes, ma'am. So you have to just you have to put equal to sign just after that DD.
Just after BD.
Yeah.
Okay.
Yes.
After that, I have to put my arrow here, right? Control R.
Ma'am, after that equal to sign, na, you have added one simple bracket, open simple bracket. Just remove that.
Okay.
Okay. And
Professor?
press control R. Just press control R. Okay. Now your code is ready. Press control button and R. No. Yes, it is right. Yes, right.
Control R.
It will open error in the read.csv. Oh, file dot choose. So which file you are choosing? File dot choose. Just click on that again. So are you reading CSV file or any other file? So probably you have saved that file with XLSX.
Yes, XLSS.
So then it will not work. So you have to store that file as a CSV.
Okay. Got it, sir.
Yeah.
I will do it. Thank you.
Okay. Yes. Yes, Yogesh sir.
Sir, I have put the command of table, but I'm getting an error on that.
Okay, could you?
I'm not getting anything after the putting the entry.
Yeah. Could you please share your screen?
Sure, sir. Sir, are you able to see my screen now?
Not yet, but yes, now it is visible. Yeah.
Yes. So after this table entry, I haven't received anything.
Okay. D, but command is running properly, no problem. So if you want to see the output
Yeah.
of table command,
Okay.
you have to type that T again just below that command.
Okay.
Okay,
D.
so T,
T.
because T, you have capital T, because you have stored that output of table in that capital T.
Okay.
Just press Control Enter. Sorry, Control R in your case. Yes.
Okay.
So this is the output of table. Now,
Okay, sir.
put this T inside that PI command, PIE.
T inside the py command.
Inside the PI command, PIE,
PIE.
PIE, small piecer. I think it is capital. Yeah.
Okay.
PIE, yes. Simple bracket and T.
Bracket.
T. Yeah. T.
Capital T.
Yes. And complete the bracket. Press Control R.
Yes, I got it.
Yeah. So, sir, if you are done with this, you can try with
Sir,
other
I
way.
have a problem.
Sure.
Can I
Sure,
share
sir.
my screen?
Okay, sir, start your session, sir.
Thank you. Thank you,
Yes,
sir.
sir. Yes, sir.
Okay,
So
thank you
now,
so much, sir.
Share my screen, sir. I have a problem.
yes, yes.
So basically, we give dollar command when we have to get the total number, like we have got arts, commerce, and economics.
No. Basically, dollar sign is used to extract that column in R. So you have gave that DD dollar faculty, na?
Yes, sir.
So it means you are extracting the column faculty from your data set DD.
It will itself choose the from the categories. It will, if there are more categories, it will give 4 categories.
Yeah. We need to give that 4 different variables. Okay,
Okay.
you need to choose it. Yes.
Sir, can we run it directly like we are first with the dollar sign, we are getting the data. So can
Yes.
we do it directly without retrieving?
And no, ma'am. Actually, that is not possible because R is reading that your entire data table as a single table. Okay. So it's not reading that variable separately. We did purposefully R that read each variable separately by using that command. Or
Shantaram, sir, your voice is not audible.
sorry,
So table is the command that we are giving.
table is the command it is used to create a discrete frequency distribution. Basically, the table is actually gives us the output of how many observation belongs to certain category. Okay, so you might have seen that 81 just below the arts. So it means there are 81 students from arts faculty. Okay, you have seen 70 just below the commerce. It means 70 students from commerce faculty. Likewise.
Okay.
Yeah. Yes.
Sir, can you see my screen?
Yes, ma'am. It is visible. So DD is equals to read.csv. Just put simple brackets. Simple brackets, not the square one, ma'am. So maybe you can, yes. And inside that, you have to put that file.choose. Maybe you can copy that code from chat box. That will be easier. Just check the chat box. Yeah, the code might be available somewhere. Let me share it again if you're not able to. So copy this entire code. Yeah, I'm sharing that entire code in the chat box again. Yes, copy this entire code. First line is not selected. Yeah. Yeah. So just remove that read.csv which you have typed. Okay, fine. Okay. Now run this line, just pressing the Control R. That's the first line. No, Control and then R. Control R.
Yes, sir.
Does it opening something, new window? Getting it?
Sir, is it possible to enter the all entries at a time?
Sorry, sir. Is it possible
Is it
to
possible
extract all variables
enter all
at a
entries
time?
at a time, at a single time?
Yes, yes. Let me just share the screen. Okay. Share the entire screen.
Sir, after every command, do we have to write again F and again T to get the output?
If you want to check that output, if you are interested in checking that output, otherwise it is not needed. Okay, so now hope you are able to draw a pie diagram in the R. So same information which you have stored in the T can be used to draw a bar plot. Okay, same frequency information. You have to just type that command bar plot of T. Okay, all letters of R commands are in a small letters. Okay? Just press Control R, and if see code is running properly, it is not giving any error. Okay, so sometimes that output is not visible directly. You need to click on Windows. Okay, Windows, and see R graphics. Okay? So I am clicking on that R graphics. See that bar chart or bar plot is created. Okay, just try with this bar plot.
Sir,
Yes.
there is no windows in RStudio, so what we have to click, sir, to see that?
In R Studios, there will be separate window. So is it not visible to you?
No, sir. After bar plot, I pressed Control Enter, but I can't see it.
Okay, just so there are 4 parts in R Studio. Na? One is the editor one, just below that console.
Yes,
On
sir.
the right hand side, right bottom side, you can
Yes.
check some options. There are plot, help.
Plots
Okay.
is there.
Yeah, click on plots. So is it visible now?
No, sir, blank is coming. Probably should I press Control Enter again? Or
Yeah.
should I command T again?
No. Command T is not required. Just you need to run that bar plot inside that bar plot. You have to put T.
Sir, may I ask question?
Yeah.
Sir, now my file error is not coming, but view DD. If I am pressing view into bracket DD, the file is not opening actually.
It is not opening. Okay.
Yes.
Ma'am, we will discuss this later after this session. So
Okay, sir.
I
No
will
issue.
check your code personally. Okay. So don't worry.
Okay, sir. Okay.
So meanwhile, we
So
will
how
try.
we will get all these codes, whatever we want to do, where will we get the codes? Like whatever you are saying, that is coming now. But
Huh?
otherwise, how we will get these codes?
See, ma'am, on internet everything is available. So you can make use of ChatGPT. It is the best one. So you can ask ChatGPT, please provide me a code for a bar plot. So it will give you a code for a bar plot. You have to just copy paste in R and check it whether it is working or not. That's it.
Now,
Sir, may we get the recording?
one more thing I want to ask. Like we have got the pie diagram. Now how we will be using this diagram for our reasons?
Yeah, you need to extract these diagrams or plots from this R Studio. Like here, I have a bar plot. So I'm clicking on that bar plot. Okay, I'm right clicking on that bar plot. So I'm copying it as a meta file or bitmap, and or you can save it for your future use.
Okay, and then directly from there we can use it.
Yeah, there.
Okay, sir. Thank you.
In fact, this
Sir, may we get the recording of this session, please, if
I don't
possible?
know. You need to check with organizers.
Ma'am, all the session are recorded and I'm providing in your email ID after the whole session. Please don't worry. Continue this session.
Okay.
Okay.
Yeah. In bar plot, if you see that some gray color bar are coming up. Okay, so sometimes we need some colorful graphs. Okay, so you just need to add some arguments. Okay, after t I'm adding argument, let's say kind of coal is equals to, I'm giving three colors, one, let's say 1 2 3, because I'm having three bars and I want to give three different colors, so I'm giving three colors. I'm just pressing it. Okay, so now the colors are changing. Okay, so that you can easily identify that faculty is changing. Okay, or if you are not happy with these colors, if you are not happy with this color, you can type the color names. Okay, so either you can do this way, or
So how did you change the color, sir? Please tell.
just check my R editor window. After t I have added comma and then type col, col is equals to 1 2 3, 1:3.
Sir, I forgot to write COL,
Uh,
and now my bar chart is divided like arts is one part, commerce is two part, and science is three part. How can I undo it?
Actually, ma'am, you can type col in front of that 1 2 3 and rerun that code again.
No, but this is not seen equally. मतलब आर्ट्स वाला जो कॉलम है वो बहुत छोटा हो गया है, कॉमर्स वाला उससे बड़ा है. मतलब मैंने डायरेक्टली 1:3 टाइप कर दिया था.
हाँ मैम,
उसको मैं ठीक कैसे करूंगी? मतलब इफ वी हैव डन समथिंग और उसको करेक्ट करना हो तो कैसे करेंगे?
उसको करेक्ट करना है तो आर कोड करेक्ट करो. सो बार प्लॉट में जो लिखा है ना आप,
हाँ.
उसके जस्ट आगे लिख दो COL इज इक्वल्स टू, और अगेन प्रेस कंट्रोल आर और कंट्रोल एंटर.
ओके.
2 महीना और रुक जाओ, खुद ही आ जाएगी.
बार प्लॉट, और if you are not happy,
Sir, your mic is not audible. Shantaram, sir.
so it is automatically getting blocked, I guess. I don't know. Yes, again going back to this bar plot. See, if you are not happy with these colors, you can just type different colors in a vector. Okay, so I'm using that combine function, and in combine function I'm typing that color names in, let's say, red, then blue, and green. Okay, in double quotes, green. Okay, and running it. Okay, so that new color will be there for your bars. Okay, I'm just pasting this. Yeah, very good. So just try it and let me know whether you are getting the correct one or not. Okay, yes, very good, ma'am. Fine. So you are getting something in your output. So now I don't know the names or the plot which I have constructed. See, I want to report this plot somewhere. Okay, I want to add this plot in some report. See, I haven't added any title to this graph. So you can add title to this graph with the help of, let's say, main. Okay, so main will gives us the main title to the graph. Okay, so in main I'm just typing in double quotes that this is the faculty wise respondents. Okay, faculty wise respondents, again running. See, now you can see the title to this bar plot. Okay, so again I'm copy pasting this in the chat box. See. Yeah, Very good. You are actually trying. So I know it is a little bit difficult to learn R software, but it will reduce lot of efforts. Okay. So when you are using Excel, you have to actually find this counts, okay, manually by using drop down, by using filter method. If you are not good at using that pivot table, okay, if you are able to use that pivot table and all, it will be more easier. But if you are not able to use that pivot table, in that case, that using Excel will be little bit difficult. You have to convert this into the data into this frequency table, and again you have to apply that pi. You have to select the graph for that frequency distribution. Whereas it will be coming in 2-3 lines in our software. It is, as a student of statistics, I'm always find easy to use our software, but it needs some practice.
Sir,
Yes.
can we directly give the data like arts is 81, whatever the data is there? If
Yes.
we directly give the command, can pie chart can be still make?
Yes, 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 ma'am. So let me just show you. So this is what we are doing in the yes, yeah. Are you able to see the PDF file? That following table is the mode of
Yes, sir.
yeah. So these are the different mode of transportation and number of employees are there. Okay. So this is the basically typical question in 9th and 10th standard. Okay. And we want to represent this information through some graphs and diagrams. Okay. So I'm typing this information in R now. Okay. So because I'm having it, so modes of transportation. Modes of transportations. Yes. So different modes of transportation I'm storing in M. Okay. I'm creating a vector. In this case, by walk, there are 45%. So I'm adding by walk is the first category. By walk. Then second category is of bicycle, then train. So bicycle, then train. So it is now this is the tedious job. You have to type the data. Bus, two-wheeler and four-wheeler. Bus, then two-wheeler and four-wheeler.
Amol sir, we'll be needing the recording of this session. Otherwise, we'll forget all this.
Don't worry, ma'am. I give all the videos, all the session. I'm sending in your email ID.
Yes.
So you'll be sending this recording?
All session recording, ma'am. Day first to last date means.
So because this is practical thing now, we will.
I know, ma'am. It is a practical thing, and next section 1 to 5 all practical. Means tomorrow you start the SPSS software. So I will be provide the all the session in your email ID, and after complete FDP program.
So you will be mailing or putting it in the group?
I am mailing and also putting in group.
Okay, thank you, sir.
Welcome, ma'am.
Sir, it would be great if you could say all the details every day.
Okay. So I have typed this data. You may copy paste it from chat box. Let me just share it with you. Chat box. Yeah. Yes. And so I'm running this with the help of Control R button. So I want to run this M. So pressing Control R. Again on the second line, employee, number of employee, I'm coming and pressing Control R. Okay. And now see, I'm simply using pi command. Okay. All PIE in a small pi and simply typing EMP. Okay. Where E is, I have used capital E. So EMP. So it will draw a pie chart. check whether you are able to get this pie chart.
Yes, sir. Thank you,
Oh,
sir.
yeah, it's very easy. Again, see, there are 6 different categories: by walk, bicycle, train, bus, two-wheeler, and four-wheeler. But here in pie chart, numbers are coming up. Okay. Instead of these numbers, I want the actual labels. Okay. So by walk, bicycle, train, bus, and two-wheeler. So I'm simply adding labels, that labels option in this case. Okay. Labels is equals to M, in which I have stored the mode of transport. Sorry, something wrong. It uses error because, yeah, label command, label missing, label. Yeah, this is the correct one. Labels. There was mistake in this. Yeah. See, now you will get the labels for this each category. Okay. Okay.
So this can be copied in Word file then?
Yes, yes. We can copy this in the Word file and create a report, nice report. In fact, if you are using the R Studio, you can directly get the PDF report from R Studio, but some packages are required for that purpose. So it is very helpful.
So can I ask
Just
one
like
question?
exporting.
Yes, ma'am.
Sir, in our data, suppose we want to make a we want to make a bar graph for this parents' income, for example. So what will
Yes.
be the code that we'll be using? We'll be using table, first of all, I think we'll be using T is equals to table, bracket, no. I think
Yeah.
first of all, we'll be doing DD dollar parents' income. What?
Yeah, right, ma'am. Yes.
And then I tried that. Then we got the income, right? Then
Yes, yes.
next step will be T is equals to table. Then bracket में P हमें लेना है. जैसे पहले आपने F लिया था फैकल्टी के लिए, तो अब
Right,
पेरेंट्स
right.
इनकम के लिए हमें क्या लेना है?
पेरेंट्स इनकम आप जिसमें स्टोर कर रहे हो ना, वो वेरिएबल नेम लेना है. जैसे कि मैंने फैकल्टी का एफ लिया था, यहाँ पे मैंने फैकल्टी स्टोर किया था एफ में. तो अगर आप यहाँ पे पेरेंट्स इनकम चूज करते हो तो आपको
सर कहाँ पे आपने स्टोर किया? हमें कैसे पता चला वो?
let
आपने
me
T
show
is
you.
equal table bracket F लिखा था.
Let me show you. Let me show you. See, I want list. In DD, I have parents income, right? So
Yes,
let me
sir.
just check the names of data. So that yeah, these are the names of data. Parents income is with this name. So
Yes.
DD में से मैंने parents income निकाला, paste किया. Okay, and I'm storing it, say PI, parents income. I'm storing in PI. So this you can choose anything. Okay, so whatever I have written in the left side of this equal to sign, you can give
Okay.
any name. So right now I am storing that parents income in PI. So if I again type PI just below this code, okay, see, it gives us me different values in that variable. Okay, different responses. Now I can create a table. I'm storing it, this table in T1, table of this PI. Okay, table of PI, sorry, PI. Okay, so table is created. I can check that table. Okay, so this is the table which we have created in the income. Let's say 3 to 6 lakhs. There are 57 respondents in income group. 6 to 9 lakhs. There are 55 respondents, and so on. Okay.
Okay.
So
Okay.
you have to just use this table in bar plot. Your bar plot will get created. And since I have stored my table in T1, I'm using T1 in bar plot. Okay, see, let me just show you bar plot. Yes, this is the bar plot. Okay, and the
Okay.
last
Okay.
is very big, so that is missing.
So for every question, we can give a code and then we can generate anything we want.
Yes, yes, absolutely,
Okay,
ma'am.
okay, okay. Thank you, sir. It's very nice, sir.
So actually, what is happening? So this is kind of repetitive work, na? So let's say I want to draw a bar plot for all the variables in this data. Okay. all the variables in this data. And let's say in this data, I have, let's say 30 variables, 30 different variables. So in that case, in Excel, if I'm using Excel, I need to go and check each and every variable. Instead of that, in R, if you are using the advanced R, if you are good at programming, you can do it in a, let's say 4 lines of a code. Okay. So all the bars will be in a single frame. You will get, let me just show you for this 3, 4, 5 variables. Okay. So third, fourth, fifth, sixth, seventh. Okay. So it is very, very useful. So let me just write. So for, let's say I in, let's say how many columns I want? Third, fourth, fifth, sixth, seventh. Third to seventh. Third to seven. Yeah, I'm selecting third to seven, and data is from DD. So I'm selecting the column from DD, ith column. I know it is difficult for you to understand, but still I'm just explaining to you the applications of R software so that you can go at home and check the R codes. Okay. So I'm just creating a table of this table of V. Let me just show you table of V. I'm storing it in, let's say T2. Okay. Same lines of code I'm typing over here, and bar plot of T2. Okay. And I'm just dividing the graph window because third, fourth, fifth, sixth, seventh, 5. No? So var mf row is equals to 2, 3. Yeah. Now bar plot of T. See, for us 5 different bar plots I have created out of this code. Okay. So you can see. So is it visible?
Yes, sir.
Yeah. So in a same lines of code, but I'm using it slightly differently, in different fashion, and I'm able to get all the bar plots in a single out of this R commands. Okay. But this is the advanced level. Okay. So even I can change the number of variables from here, let's say 3 to 10, and I'm giving some, let's say 3 to 3, 9. See, so I can just changing the number and getting all the bar plots. Okay, same can be done with the pie chart as well. Okay, so this is the applicability of R software, where you can do the repetitive kind of work in just minutes and seconds. Okay. Yes, so yeah, we are not able to finish the content, even though it was just a content of 18 slides. I would like to go back to the content now. Okay. So in this way, you can draw the graphs and diagrams. Okay, I'm not worried about finishing this content, but I just want to make sure that you people are interested in this or not. Okay. Yeah, this we discussed cleaning of the data. Okay. So when you are collecting the data without consulting the statisticians, so you may end up with some vague data, and that data need to be converted in the proper fashion, and it requires some time. So so the purpose is, so if any of your friend is working in the statistics domain, so please connect with them and collect the data appropriately. So data reshaping is the one case where we want to transfer our data in some other variables. Okay, so I'm not going into much details of this data reshaping. Okay, then graphs, plots, and diagrams. So we have discussed the bar diagram, bar plot, line chart, box plots, and histograms. Okay, this can be learned by when, if you are interested. Okay, so if you are interested, you can go and check online. There are number of sites. Okay, so on which you will get the R codes, So you can just copy paste that R codes, their data, try to run this in the R software. If you are getting the output, it's well and good. Otherwise, you can again try to identify that error, recheck, and you can correct your code and will get the output. Okay. So yeah, so this is the graphical representation of the data. Now summary statistics. Okay, so graphical methods are little bit vague. Okay, vague means what? So the conclusions drawn from the graphs can be changed person to person. Okay, some people might find that graph is showing something. Some people might find that that graph is showing something else. Okay, that might happen with the graphs. Okay? So usually, as a statistician, we always recommend numbers with the graphs. Okay, numbers with the graphs will be the beautiful combination so that everyone can understand the data well, and it will help us to take the decisions. Okay, so with the numbers, sorry, with the graphs, you have to always come up with numbers so that the conclusions drawn from the numbers will be same for all the persons. Okay, irrespective of the person, that conclusion will remain same. Okay. So there are some measures of central tendency which we have seen in the our 10th class, 9th class, mean, median, mode. So those who are from Marathi medium can learn that madhya, madhyak, and bahulak kind of thing. Okay. So weighted mean is some weights are given to that variables. Harmonic mean, geometric mean, this is again not commonly used, but geometric mean and harmonic mean is very much important for the economics. Okay. The people from economics are commonly using this. Basically, the changes in the interest rates, can be measured with the geometric mean. The average change in the interest rates or any rates are always represented by the geometric mean. In that case, harmonic mean is not used. So literature is available everywhere. So you can just go and check the literature. Okay. So yeah, these are the measures of dispersion: range, quartile deviation, variance, standard deviation, and so on. The coefficient of range, relative measures of dispersions, again, out of which variations is commonly used. Measures of skewness, kurtosis, all these are available. Okay. So now this is the testing part, which is required in the required for the social science people. Okay. So I know it is now very difficult to cover all this testing because it required a lot of time. So Amol sir,
Yes, sir.
is it covered in any of the sessions, previous sessions?
No, sir.
Okay. So I need to touch. So I don't know whether
Sir,
participants.
null hypothesis and alternate hypothesis was covered yesterday.
Okay, okay. So let me just revisit then. We still have half an hour, so we will discuss this. Null hypothesis is the basically hypothesis with no difference. So we are not assuming anything. Okay. See, let's say I have a data. Let's say this BDD data. Okay. BDD data, and I have variables like clearly. Yes. See, the question is, how would you rate your satisfaction with your physical appearance? Okay. So does it depends on your gender? Okay. So maybe girls are more concerned about their physical appearance than boys. Maybe some boys are also concerned with their physical appearance. That is possible. But does this physical appearance of a person depends on the gender? Okay, that is my research question. Let's say, okay, but null hypothesis. So my hypothesis is does the physical appearance depends on the gender or not. Okay, so my null hypothesis will be that the gender and physical appearance are independent. Okay, they are not dependent in each other. Okay, so that is the my null hypothesis. So I am assuming that so that physical appearance and gender are independent of each other. So hypothesis with no difference. Okay, whereas alternative hypothesis, which is always complementary to the null hypothesis. Okay, so in the alternative hypothesis, I'm considering my belief. Okay, so my belief is they are dependent. Okay, gender and physical appearance, satisfaction in the physical appearance are dependent. Okay, that is my alternative hypothesis. Hypothesis with difference. It is called hypothesis with difference or complementary hypothesis to the null hypothesis. Okay, so that is the basic difference in the null hypothesis and alternative hypothesis. So as a researcher, our hypothesis under study, okay, hypothesis under study will always go into this alternative hypothesis. Okay, and the null hypothesis is the hypothesis in which we are not assuming anything. We are not assuming anything. That is the alternate null hypothesis. Okay, and the taste statistics is the important concept. Okay, taste statistic is basically a term or a function of sample values. Okay, basically it is determined from the data values. It is determined from the data values, and based on that, we are taking the decision whether to accept null hypothesis or reject null hypothesis. Okay, and this p-value is another criteria to whether to accept the null hypothesis or reject the null hypothesis. Okay, usually we are talking in terms of p-value. Okay, and we are comparing this p-value with this level of significance. Okay, so as of now, I'm just explaining the chi-square test of independence of attribute. But chi-square test of independence of attribute is used when the data is measured on nominal scale or ordinal scale of measurement. Okay, when the data are measured on nominal scale or ordinal scale, in that case, chi-square test of independence of attribute is used. So as I said, whether the physical appearance depends on gender or not. So here, two attributes are coming. One is physical appearance and second one is the gender. Okay, these are the two attributes, out of which gender is measured on nominal scale. It is just a named category. Okay, whereas physical appearance is measured on ordinal scale. Okay, where some options are given to the students. Yes, we rarely feel that physical appearance is good physical appearance is required. Sometimes we feel that okay, we are satisfied with the physical appearance. We are not satisfied with the physical appearance. We are rarely satisfied with the physical appearance. So on. So these options are given. So it is measured on the ordinal scale. Okay. So you have to set up the null hypothesis. In that case, so null hypothesis in this case that gender and physical appearance are independent. Okay. Alternative hypothesis will be two attributes, gender and physical appearance are dependent. Okay. Then we need to calculate the taste statistic. Okay. This taste statistic is calculated, and so this is taste statistic for chi-square test of independence of attribute, where this OIJ denotes the observed frequency. Okay, observed frequency, and EIJ denotes the expected frequency. Okay, so we will just perform this test in the R software, and we will try to get something. Okay. If p-value is less than level of significance, then we reject the null hypothesis. Okay, if p-value is less than level of significance, then we reject the null hypothesis. So we reject the null hypothesis. It means alternative hypothesis is getting accepted. So if we are able to reject the null hypothesis, then we may conclude that two attributes are dependent. Okay, two attributes are dependent. So let me just try to perform this test, chi-square test of independence of attribute in R software. Okay, it is very easy. You have to just make use of table command. Okay, so let me just show you.
Can you please share this existing code in the group? US code, that is par,
Yes, sir.
MS, row.
Yes, sir. Yeah, let me just show you. Let me just paste this code.
Okay, thanks very much, sir.
Yeah. Yeah. So going back, our software. Yeah. Now I have a data stored in DD. Okay, we have already imported data, and data is with us. And just again checking the names. Okay, names, and where the names of DD are like this. Okay, so out of which I want gender, and see this question number. Question number with the satisfaction, physical appearance. And yes, it was the yes, it was the question number 5. But the variable name is very big. Okay. Yes, it is not possible to copy that entire name. Okay, so I'm using some other way. Okay, so I know it is at 12th place. Okay, it is at 12th place in that vector. So I'm using DD square bracket. So square bracket over here. So I'm selecting that 12th variable. Okay, 12th variable. So don't worry about this. So physical appearance, PA, I'm storing it in PA. So this is the response for the physical appearance. Okay, so this using a square bracket is another way to extract the variable. Okay, so square bracket is used to extract the variables. Okay, so there are two ways to extract the variables. One is that dollar sign, and second one is this square bracket. Okay, so PA, I have physical appearance, and now gender. So DD dollar gender. Okay, so gender values are there. Okay, now I'm storing it in G. Okay, so now instead of a table of single variable, we can construct table of two attributes. Okay, so I'm now passing two attributes in the table command. Earlier, to draw a bar plot and pie chart, we used a single variable. Okay, now I'm using two different variables, gender and physical appearance, in the table command, and it gives us something like this. Okay, so this gives us the contingency table. This table is called as contingency table. It is called as bivariate table as well. Okay, two attributes. So there are 11 females who are dissatisfied with their physical appearance. There are 15 males who are dissatisfied with their physical appearance. Okay, so likewise. Okay, so you can interpret in this way, and this table I'm storing in, let's say, T2. Okay, you can use any name. Okay, and this table, just I want to pass this table into chi-square test. Chi sq.test. Okay, so this is the R command used for a chi-square test. Okay, chi-square test, chi sq.test. Okay, and just press Ctrl R. See, it is giving us something. Okay, some output is given. So out of which this value chi squared x squared, okay, is the value of chi-square statistic. Okay, is the value of chi-square statistics. So this test statistic is nothing but that x square value. So in this case, we are getting the value of test statistics as a 4.4395. Okay, so either we need to compare this value with some value of chi-square distribution, or you can directly compare this p value with level of significance. Okay, so usually level of significance is stated as 0.05. Okay, so if p value is less than level of significance, then we reject the null hypothesis. Okay, so here our null hypothesis is, let me just type the null hypothesis. It's not null hypothesis that two attributes, gender and physical appearance, physical appearance are independent. Whereas alternative hypothesis is H1, it is attributes, gender and physical appearance are dependent. Okay, I'm just copy pasting. Yes, physical appearance are dependent. Okay. Yes. So if reject null hypothesis, if p value is less than LOS, level of significance. Okay. See, we have set it up that null level of significance at 0.05. Okay. So p value is this 0.3498. So which is not less than 0.05. Okay, which is not less than 0.5. It is in fact greater than 0.05. And we are rejecting the null hypothesis if p value is less than level of significance. So what is the decision in this case?
Accepted the null hypothesis.
Accept the null hypothesis, right? So our conclusion is this. Conclusion is attributes are independent. Okay, so this is our conclusion after applying the test procedure. Okay, and we can't draw this conclusion just by looking at the data. Okay, because data is very huge, large amount of data is there, so we can't just check and draw a conclusion whether they are dependent or independent. Okay, so we need to apply this test procedure, and so the application of this statistical tests is, so this result is now valid for the entire population of students. Okay, and all this conclusion is valid for all the students in the particular college. So this survey is for SP college students. So this conclusion is valid for all the students in the SP college. Okay, so that gender and physical appearance are independent. Okay, so in this way we can run the we can actually write a code for such tests in our software. So this is just an example. Okay, so another one is the proportion test, which is again very commonly used by the people from social sciences. Okay, proportion test, because your data is mostly measured on the nominal scale and ordinal scale. So proportion is the only way to represent your data. So whether the proportion of student, whether the proportion is same or it is not same in the two groups. Okay, so that might be of interest. Okay, for example, in this data, one might be interested in that proportion of proportion of people from, let's say, lower income group is more than the proportion of people in higher income group. Okay, so that can be one interest, and that if you want to check it for the entire population, you have to perform the test procedure. Otherwise, that conclusions drawn from the sample will not be valid. So you have to apply the test procedure to generalize your result from sample to the entire population. Okay, so this basically testing procedures are filling the gaps between between sample and population. Okay, so that conclusions drawn from the sample will be valid for the entire population. Okay, so I guess we need to stop here. If you have any questions, you can ask. Okay, so we can discuss.
Sir, in the earlier question that you had done, my chi-square is coming about to be 5.5 and degree of freedom is 8 and p-value is 0.7. How is it that I'm getting a different value?
Okay, so are you using the same data?
Yes, sir, your data only.
Okay, so let me just check my answers. Yes. So what is your values? What are your values? Hello? Hello, ma'am. Okay. Am I audible?
Yes, sir, you are audible.
Yes, sir.
Yeah, probably. Yes. Ma'am, could you please share? No,
Okay. Yes.
it's okay, ma'am. I got it. I got it. Yeah, because I changed the data slightly. That in the data, basically, the count of female is represented in that female data set. Let me just show you. Okay, ma'am, just go and check this. Okay, gender female. So just apply filter and check how many values you are having. So male and female I am having in my data. So you might have one more female value that is in the small letters probably. I have converted that into the capital letters. Just scroll down and check whether you are having that word female. In my case, it is capital everywhere. Okay. In your case, it might be somewhere might be in a small letters.
Yes,
Am I
sir.
right?
Yes, sir. There are small letters.
Yes, yes. So it is creating some difference, right? Okay. So this is the data issue. So we need to convert this data appropriately. Okay. So that's why we usually represent the data in numbers. Okay. So we will simply replace male by 1 and female by 0, or female by 1, male by 0. So that this ambiguity will be avoided.
And so these are the observed frequencies that we are doing.
Yes, yes. This is the observed data. Yes.
And from where it is taking the expected one?
Expected one, it is automatically calculating, ma'am. That R command is automatically calculating.
Okay.
Yeah.
Right.
So if we want to check, see, if we want to check, you can store this output. See, I'm storing it in capital C, or let me CH, capital CH. Okay. So, and I'm just checking names, or I'm just printing that CH. Okay. Object, yes, capital CH. CH. So let me just check the names of CH. Again, it is small. See, so this much information is stored just behind this chi-square test. Okay, while displaying, it is just displaying this much information. Okay, but if you check the names of this chi-square test, this much information is stored. See, the expected frequencies are also there. Okay, so I'm just typing CH dollar. I'm extracting expected. Okay. Expected. See, these are the expected frequencies. Okay, and whereas the observed frequencies are, I just need to type observed. See, these are the observed frequencies. So by using this expected and observed frequencies, it is calculating that chi-square statistic. Is it okay, ma'am?
Right, sir. Thank you so much, sir. It's a wonderful presentation, sir. R has been always, sir, something that, I have always felt that it can't be understood, sir. More difficult part.
Yeah, actually, it is, if you spend some time on it, it will be just a fun. Okay. So if you are daily spending, let's say, half an hour on R, and you are just using or copy pasting the codes given by the ChatGPT or some online source, still you will get something. Okay. So it will be more easier for you to learn. Earlier, that online resources were not available, then at that time it will be difficult. But now ChatGPT is coming. So by using ChatGPT, you can learn any kind of programming.
So we can get the commands from ChatGPT. That is.
Yes. So you have to just pass that appropriate question to ChatGPT. So if you want to perform the chi-square test in R, just ask ChatGPT that please provide us a code for chi-square test in R. So it will give us support.
Right, sir. Thank you so much, sir.
Thank you, ma'am. So yes, any questions? So sorry, I haven't. Yes, Mohammed sir. Yes.
Sir, for econometrics, can you suggest any books or anything, any thing through which R can be made easy?
Yes, ma'am. Lot of books are available, but I suggest you not to go for the books, because now you have lot of online sources where you can read the commands, as well as you can understand the theory well. Okay, you can copy paste that code easily and all that stuff. So there is one book and that is Statistics using R, a book by Sudha Purohit madam, Deshmukh madam, and SD Gore sir. So this is the wonderful where you will get all the details about the statistics and R as well. So it is the book which covers theory as well as R codes.
Sir, for R, is there a better online source that we can have?
Thank you, sir.
Yes, yes. There are a lot of sources. So you can check W3 school website, W3 school's website.
So can you please type it in the chat?
Yeah. Let me just check W3 schools R programming. Yes, R tutorials. So these tutorials are available from beginning, okay, from scratch to masters. All sessions are available. So you can daily, even if you check one session, it will be really good. And that Greeks for Greeks is also helping me sometimes. Greeks for Greeks. R programming. And data flare is one more, which is also very good. So this is the Greeks for Greeks. Let me just show you. And one more is data flare.
So which one was the second book after W3 schools?
Greeks for Greeks. Data flare. R tutorials.
Okay.
So I have pasted these links in chat box. Yeah, this is also good. Data flare. More for tools for calculate method to use for calculate average. So, sir, calculating. Sorry, ma'am, Neetu, ma'am, calculating averages. So you need to understand first the data types, whether that data is measured on nominal scale, ordinal scale, ratio scale, or interval scale. So you are able to compute the averages only for the data measured on ratio scale. We can't compute average arithmetic mean basically for the data measured on interval scale, nominal scale, and ordinal scale. But yes, at the place of average, you at the place of arithmetic mean, you can use median or mode. Okay, so to represent or to compute the central tendency of the data.
Thank you, sir.
Yeah, welcome, ma'am. So the learnings from this session is understand the 4 different scales of measurements and the statistical techniques which you can use based on that 4 different scales of measurements. That's it. Okay. So once you are learned that 4 different scales of measurements and techniques which are applicable on that measurement scales, you are done with the statistics. Okay. At least the basics which required for you. Yes. Mohammed sir, you have raised your hand. Any question?
That hypothesis testing is there, right?
Yeah, hypothesis testing.
Sir, can you please just share that is chi-square particular code, sir?
Yes, sir. Yes, sir. I'm sharing it once again.
डायरेक्ट आहे ना सगळं लागलं त्या माणसाला.
Yes, sir. I have taken sports and I'm also sharing this slide with. Yes, sir. Facing the course. Amol sir, shall we stop here?
Yes, sir. Yes, sir.
Uh,
Thank you, sir. I
Yes.
hand over to session Dr. Pratik Shinde, sir. Shinde, sir. Pratik, sir.
Yeah, sir. Just a minute.
Yes, please take a vote. Thanks.
I'm audible, Amol, sir?
Yes, sir. You are audible.
Yeah. So thank you very much, Amol, sir. Here I am presenting for the vote of thanks for the 4 days, session number 6 of 10-day national online capacity building program on research methodology and magic of statistics, organized by the PDS Professor Ramkrishna ECS College, Pune, has been remarkable journey of knowledge and skill enhancement. First and foremost, I extend my heartfelt thanks to our respected guest speaker, Professor Shantaram Dhum sir, whose insightful session on statistical method for data analysis in social science added significant value to our understanding. Your expertise and passion have truly enriched our learning experience, and we are grateful for your valuable contribution. I would like to express my sincere appreciation to our Principal Dr. V.G. Lobo sir and Vice Principal Dr. H.B. Sonawne sir for their constant support and encouragement throughout the program. Your guidance has been instrumental in the success of this event. Last but not least, I express my sincere thanks to all participants who have actively engaged in the statistical session, making these programs in the vibrant and interactive learning experiences. Your interest and dedication have been driving force behind the success of these initiatives. Thank you everyone for being a part of this enriching journey. We look forward for future collaboration and contributes the academic growth and research excellence in our institution. Thank you everyone. Thank you so much.
Thank you, sir. I conclude that today's session are finished. Tomorrow, same time, same place. Please download the SPSS. I forward the video of SPSS in our FDP program, and this instruction are followed that. Okay. Thank you so much participation. Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you, Amol sir.
बहुत बहुत धन्यवाद सर.
Welcome.
Thank you so much.